So in our previous video, we established that our limiting reagent between the hydrochloric acid and the magnesium that we had would produce 4.57 liters of hydrogen gas at STP. So we assumed that all of the hydrochloric acid would be used up. But what about the excess reagent, the magnesium? We can easily figure out how much magnesium would be consumed in this reaction, and as being the excess, how much would be left over. This can be done simply by making the magnesium the unknown. And we can use either the limiting reagent as our known, or if we want to, we could actually use the theoretical yield as our unknown. It really doesn't matter. As long as we do our correct stoichiometry, the answer will be the same. In this case, I decided just to go ahead and reuse the hydrochloric acid all over again, converting it to moles, now making the magnesium our unknown over known, and because the magnesium that we started off with, which was 6.5 grams, was in mass, we multiplied by its molar mass, and it tells us that if we truly were to get this theoretical yield of hydrogen gas from 14.9 grams of hydrochloric acid, that means that the equivalent amount of magnesium used would be 4.97 grams. Furthermore, from this we can determine how much of our magnesium would theoretically be left over simply by subtracting the amount that was used from the amount that was available. So if we had a perfect reaction happen, which we know doesn't really happen, we would have a consumption of 4.97 grams of magnesium and 14.9 grams of hydrochloric acid to make our volume of hydrogen gas, and actually have some of our excess reagent of magnesium left over to the tune of 1.53 grams.